Hello and thank you for stopping by. Today I bring to you a video on a subject that I have been kind of pondering over the last few months, and it is about what are the factors that are enabling certain technologies to grow at scale. Consequently, as these technologies are growing at scale, it is solving different kinds of problems again at scale, thereby altering industry structures on the problems that they are intending to solve. Essentially, the way we look at the world is going to be transformed radically. We need to understand the context of this transformation and what are the factors that are leading to this transformation to know whether this is a mere blip or is this change going to be sustainable over a period of time. And today's video is about a framework that I have created to understand what is actually happening in the technology space, and as a result of which what are the vectors of change, the nature of problems that is going to solve, and the kind of industry impact it is going to have. So I'm going to kind of tell this reasonably easy so that it's for a consumption of a person who does not have a background in technology, and also would help business leaders, entrepreneurs, educators to get a hang of the variables that are impacting civil society as we go by. With that, now let me take you to the presentation, right? So the presentation is called How Technology Will Transform Our Lives. And before we get there, it's important to understand that technologies have been transforming human civilization for centuries, and therefore for more than 300 years the drivers of economic growth have been technology innovations, and these are called general purpose technologies, which technologies when applied actually transform multiple industries and solve multiple problems at the same time, which includes categories like the steam engine, the electricity, and internal combustion engine. We know how these particular technologies transformed the world from the multiple industrial revolutions that it facilitated. Now, I'm not going to labor on these classical technologies, but I'm going to leave you with the thought that today, as we stand, the internal combustion engine and the electricity and the steam engine equivalent in our times is something called artificial intelligence. And the goal of artificial intelligence is to make systems that can function intelligently and think and act like human beings and independently without being programmed to do so. Right? So in this video, I'm hoping to achieve two things. One is to help you with a framework which will explain the timing and the implications of a combination of technologies which will change the world forever. Basically answering the question, what is leading to certain technologies grow rapidly and grow at scale. Following up to this point, I'm going to talk about the likely nature of change and the kind of problems that these technologies are solving, and thereby changing the way human beings and technologies will interact going forward, and that in the foreseeable futures, and its implications on business. So what I'm trying to achieve is to help you understand why are certain technologies growing at the pace that they are growing today. What is the consequence of this adoption of technologies? What kind of problems will be solved, and therefore how will businesses be impacted? Now let's kind of unveil the framework with its components. The first is called the technology infrastructure, or the change of the technology infrastructure. The word infra basically means that what lies below, and infrastructure are underlying structures on which everything else is built. Now, we know this intuitively. A good economic infrastructure helps a nation grow. A good physical infrastructure enables trade and commerce, and so on and so forth. These are common and intuitive understanding. Similarly, a technology infrastructure is explained in context of connectivity, which is bandwidth, the quality of bandwidth, computational resources, which is the way computers solve problems and are programmed to solve problems, how software development paradigms have evolved and propel new technologies to become more powerful and pervasive. So net, the stronger and more robust your infrastructure is, it is going to propel technologies to solve problems at scale. So this is the first block, the technology infrastructure block. As the technology infrastructure block gets strengthened, it naturally fuels innovation and improves adoption of technologies from lab scale to day-to-day use. Basically, what it means, for technologies to impact millions and alter the way of transacting business, it has to be viable at large scale, which is the price performance ratios, the cost at which the technology is coming to you and the value that the technology creates has to make sense. Therefore, a technology which shows promise at a laboratory level and cannot be scaled and adopted by millions of people is good technology but doesn't have an impact. And we're going to explore how technology infrastructure impacts innovation and improves adoption from a limited usage perspective to all pervasive use. Furthermore, as we move on, these technologies then solve problems or enable people to do things better and remove inefficiencies in the process. These wide scale horizontal applications create the scale of usage and further lead to altering industry landscape forever. Now the question to ask is, when I'm kind of unveiling this framework, it looks like a linear framework. It is not so. All of this are circular processes, which is, as the technology infrastructure improves, the adoption improves. As a result of improved adoption, more investments come into the technology infrastructure and so on and so forth. The limited point that I'm trying to make is A, B, C, and D are not linear. They are not time scale, neither are they sequential. They are reinforcing loops, if you may. Moving on. Now let's start with the technology infrastructure paradigm, and I call it the connectivity, computing, and next generation software development as the three vectors in it. Now we know that billions are getting invested into 5G and 4G networks, and as a result of which it is delivering something called low latency as a subject, as a paradigm. Now, to understand latency, latency is an important concept in networks and in connectivity. It is basically the time taken for data to reach its destination and back to its source in a network measured in milliseconds. So it is the time elapsed for data to reach its destination and back to its source measured in milliseconds, which is basically the throughput, the quality of the network. Now we have evolved from 1G, 2G to now moving on from 5G and 6G. Now 2G networks had latencies of 600 milliseconds, 3G's 120 milliseconds, 4G 30 milliseconds, 5G came down to 10 milliseconds, and at time when we are going to be 6G, it is going to be 1 millisecond or a no latency network. Now as a result of which the immersive experiences, and there will be no lag while you are going to access the network, which would change the nature of experiences that you have with your service provider or the services that you access. The low latency networks have a very, very significant impact in enabling metaverse, in enabling retail, in enabling online shopping or any online activity that individuals might be doing right now. So the better and better that networks become and stronger and more powerful they become, they enable more online transaction and high fidelity, high quality transactions. Now, with the improvement in networks and investments, and it's probably billions of dollars are getting spent in upgradation of these networks, there is something called low-powered wide area networks, which support more and more connected devices, which means more devices can be connected at a cheaper price, which enables which facilitates devices to connect and the Internet of Things to be more pervasive. Similarly, as we move on, we have low Earth orbital satellites, which is large number of much lower cost satellites which deliver wider coverage at reduced latency. So you have a set of satellites which capture data, have a much wider coverage, and deliver its services at lesser time lags. Consequent to that, these low latency networks enable immersive experiences, and an important point is to make edge computing viable. Now, most of computing, then I'll come to edge computing in a bit. Most of computing that happens is when from a device the data goes to the cloud, it is processed in the cloud and comes back. So there is a natural lag or a natural latency built in the process. What edge computing actually does, it actually processes the data in the device For instance, in your mobile phone, the face recognition is an edge computing thing, so it happens in zero latency and zero lag. Right now, the better network throughput enables high fidelity services, more connected devices, and the data flow enables multiple services, products, and experiences to be bundled more effectively, making going on the net a better and a more native natural process. Similarly, the second important thing, which is probably even more important, is how next generation computing architectures are evolving. Now, we all know of cloud versus on-premise, and now that is not the most important thing. However, what cloud really does, and most enterprises are in cloud right now, is to enable distributed computing, which means it doesn't do all tasks in one mother computer and connects with the host server in parallel processes. What it does, it takes a big complex task where these tasks are not where the tasks are not necessarily sequential, and breaks it into smaller tasks and distributes it over the network, as a result of which it actually improves the computational power, the throughput, and facilitates speedier resolution of services. So distributed computing cloud has a very significant effect. It has very significant implications on logistics, on retail, on omni-channel retail, and so on and so forth. The second important thing in computational world, as we talked about, is edge. Now, edge is basically getting the data or correcting the data near the device and not sending the data back to the cloud and waiting for it to be programmed. Now, is cloud and edge competing technologies? They are not, because the edge is used for time sensitive processing, low latency processing, and low bandwidth processing, and low volumes of data processing, while the cloud still is relevant because it has to process much larger data, do predictions, and so on and so forth. Very simple example. So in an autonomous vehicle, now you need to have edge computing for the car to understand a threat and press a brake as a command to avoid an accident. It cannot wait for even a 4G 30 millisecond latency for the command to come from the cloud, as a result of which autonomous driving, the one part of autonomous driving which is accident prevention, works on the edge, but in terms of things which are not time sensitive, which is how the car should navigate itself in the future, what route should it take, what kind of traffic problems that it should manage, is a matter of the cloud. Similarly, the other important thing is next generation computational architecture is the fact that the classical CPU based architecture, or Van Neumann's architecture, was based on sequential processing. So one part of the task is processed, then the next part, and so on and so forth, which consumes a lot of energy and bandwidth, and therefore the processing and the bandwidth are two separate activities in the Van Neumann's computer. Now the GPU, or the graphical process units, and the neuromorphic computing are basically computing which does not use sequential processing, does parallel processing, and can process huge amounts of data with the same resources, and therefore artificial neural networks, ML data, machine learning data systems are processed much better. Now this reduces the cost of processing, more efficiently uses computational resources, and the cost of computing, as the Moore's law is coming down, but more and more devices can use computing. The third important thing is spatial computing, which enables virtual 3D objects in the physical space, and therefore renders 3D objects for corrective elements. NVIDIA is doing a lot of work around that. So NVIDIA's Omniverse, digital twins are examples of spatial computing. Now, what this next generation computing is doing, at one level, we all know of Moore's law and the cost of computing coming down. But computing is becoming all pervasive, and all devices now can have computing power, making more devices intelligent as we go by. Now, neuromorphic computing apes the human brain, where there are neurons and synapses, and they do not look at binary inputs, but they take artificial neural network inputs and spike inputs to be able to process it much further and much better. So with the same computational bandwidth, the amount of data that is crunched is much higher. This enables the ability to process the big data that is now in terabytes and at speed, and enables huge number of use cases and overcomes the limitations of classical computing. Now if you look at the GPU market, or the graphical processor unit market, which was previously which was previously used only in gaming, but if you look at the GPU market share, it's there in this chart, and the CAGR is pretty attractive. Similarly, we did talk about edge computing and multiple use cases and mobility and retail. The third important thing is around software development. The classical software development is a technical process, the software development life cycle, you write code and so on and so forth. But what is really happening is the development of platforms which are no-code platforms, which means you and me, who are not technically qualified to write code and create a program, can actually do so by visually managing certain blocks. This enables a wider application of AI, and small and medium enterprises, without having the technical resources, can use technologies like AI to solve their business problems. So what it does is it creates a much wider usage space. This technology creates a much wider usage space. So as a result of the change in technology infrastructure, what is basically happening? Connectivity is becoming better. Latency, which is the lag of signals, is coming down. Computers are becoming smarter as in they have more power and computational resources without an incremental investment, and therefore they can process huge amounts of data which the classical CPU based computers would not. The third important thing, people who were not qualified to write programs can write programs, and therefore they are not held hostage to people who are developers in nature, and therefore that creates a huge scale in AI adoption. Now moving on, the next important thing is, for technologies to impact millions, you have to change the way of transacting business. It has to change the way materially of transacting business for it to gain scale. Now let's see how this thing happens. First is all pervasive AI. AI is becoming, artificial intelligence as a technology is becoming all pervasive. The first important thing is because it now has the capacity to process huge amounts of data. This huge amount of data processing is possible because of what we discussed in the previous slide of the new generational computational models, neuromorphic computing, GPU based computing, and so on and so forth. The second is more people can write code, not write code exactly, more people can create computer programs, or the citizen developer, which enables huge amount of AI adoption for medium and small scale industries. The third important thing is the distributed computing on the cloud enables efficient distribution of computing load. Thereby what actually happens, as against a central processor trying to compute different streams of data, this data is kind of broken down into multiple streams, leading to novel use cases. For instance, in travel and logistics, demand forecasting, route optimization, and schedule management are not sequential processing data. They are parallelly processed, and the output is given to the central computer or the nodal computer to do a much faster response time. Similarly, omni-channel facilitation, multiple data points from multiple channel comes back to the handheld device of the user through the process of distributed computing. The device, then the user can actually interact on an app, and some parts of the device which are time specific are actually done at the edge itself. Consequently, the second important thing that is happening is the world is becoming smart and connected, because more computational power, once is not only is computing become cheaper, but more and more devices become intelligent and can be fed with computing power because it is economically viable to do so. Second is the low Earth orbit satellites support a huge number of devices getting connected, and connected in a way where the time lag is low. Like I talked about, low latency, low Earth orbital devices. The third important thing, but this is now still in the discovery stage, is the commercial quantum sensors, which is the classical sensors, and the quantum sensors use quantum physics and the principles of quantum mechanics like entrapment, envelopment, and so on and so forth, and can detect the slightest change in the environment, producing even more smarter data, and these are high precision data elements. So at one level, The world is becoming more and more smarter. It is emitting more data. The computational power and the ability of industrialized artificial intelligence is helping people to process the data, the result of which is the ability to solve problems is becoming from a lab scale or a scientific issue to something that a common man can do. The third important element is the liftoff of immersive technologies and the building of the metaverse. Now, the brain computer interface is becoming more and more it's becoming less invasive, which means the way the brain can control the movement of devices is becoming more native. Consequently, however, in the immersive technologies, the cost of headsets, the haptics around the headsets is something which needs to evolve. And once the cost of headsets and the quality of data that it can process improves, this is going to go big time. Now, the other important thing, again coming back to low latency, is that it enables immersive experiences, which means today, while it is a gaming experience, but stepping out in the metaverse, in a decentral land, in a metaverse virtual universe to do a conversation or a communication when there is no lag, and actually replicating the physical reality is something which is going to fuel in the World Wide Web and consequently the metaverse. So the big things around this slide is that the world is becoming the equipment around us, the daily equipment around the world around us is becoming more and more intelligent because of additional computing power that can be bundled in the equipment, as a result of which they give data back to the environment. This data is obviously in petabytes, and this is big data. This big data is being processed because the computational ability of the modern day computers is not based on the CPU model, but it is based on an alternative computing architecture. The third thing is that that a lot of people are participating in building AI programs, and it is being spread away from the specialist skill set to a more generalized skill set, and all of this putting together is making the world more and more data and technology rich, and its ability to process the data also growing significantly. Consequently, the nature of problems it is going to solve. Now let's look at what kind of problems are getting solved, and therefore how is it going to impact the industry. Now, typically the classification and prediction problems, which is the goal of AI, right? Now, since we are able to process the huge amounts of data, deep learning and artificial neural networks are not and it is moving away from machine learning, the supervised, unsupervised learning, training data sets, and so on and so forth, which use huge amount of time to train the computer. The timing is becoming shorter, and neural networks is becoming commonplace. This is enabling data-driven insights across industry, facilitating personalization, and we know about personalization, but the nature of personalization, the quality of personalization, and the pervasiveness of personalization is completely changing, which means CPG, e-commerce, FMCG, retail, all of these people exactly know what you want to buy at the time of buying, leading off to how they engage with you in the purchasing journey, leading to embedded finance, and so on and so forth. So there's a whole big thing around personalization. Second important thing is precision. Now precision medicine is another big thing. Precision healthcare, where people are not given generic dosages, and depending upon your DNA structure, your mRNA responses, your protein buildup, and so on and so forth, you get precision healthcare. Similarly, precision is in mobility, logistics, and so on and so forth. And prediction is all pervasive, because now you have the data and models to be able to predict. In the case of financial services, predict fraud, money laundering, those kind of use cases, or in underwriting. So for instance, in digital lending, to facilitate digital lending for MSMEs in India, you can actually build underwriting models based on publicly available data pulled in from the APIs to be able to do so. Similarly, image and language processing, computer vision, natural language processing is aiding personalization. Voice commerce is another big thing. Now, what is voice commerce? Voice commerce is a voice command converted into programmable code, which goes into an action library and comes back with a response. And now voice commands, the Siris, the Alexas, the Google Home kind of things have an very, very big impact on the way commerce is going to be done, how homes are going to become smarter, retail, mobility, and healthcare. So the other important thing is the big picture here is we can train computers faster, by using deep neural network and artificial neural networking, which is as a result of our change in computing methodologies. Consequently, big data enables us to classify and predict better any use case which requires precision, prediction, or language processing or image processing is done at a much higher data level with a much higher precision and higher fidelity. Similarly, so this is around the CPG, the e-commerce, the healthcare, and businesses which can be digitized. Now, if you look at the classical businesses, the rise of intelligent devices is changing the way how you can track and trace a device, which has an implication on classical manufacturing, mobility, logistics, where you know the condition of the equipment based on the operating condition and where the machine is placed, what kind of features that it requires, when does it need preventive maintenance, and so on and so forth. So, for instance, condition monitoring. The condition monitoring is used for health devices. You can do our wearables, factory and maintenance use cases, remote diagnosis for healthcare. You can actually put a chip in your heart, and somebody miles away can diagnose your ECG or how your heart is functioning and can administer health solutions from far away. Similarly, for smart metering and energy. Now, the third important problem that's going to solve is the rise of immersive technologies, which is obviously transforming not only gaming experiences but also transforming online commerce, live commerce, and e-commerce, sale of products using AR, VR. And we know how IKEA actually, and not only IKEA, many other people use artificial intelligence, so augmented and virtual reality to show how their product looks in your space. And therefore, so the nature of experience, from precision, prediction, and image processing and language processing, to physical condition monitoring, to next generation immersive experiences, are covering at least 10 big industries which have a significant impact on GDP. And those icons I've put in the slide here. So banking, financial services, mobility, smart homes, commerce, healthcare, all of this put together account for significant, more than significant, a material portion of the GDP of any country. Now, if I were to put all of this together, you see the technology infrastructure is evolving, where you have low latency, which is low lag networks, high quality devices, expendable computers, which are facilitating the use of technologies at scale and solving problems differentially and more effectively. So the question, so coming back to the final question, the important thing to ask is that as the technology infrastructure of the world and different countries improve over time, they are fueling a revolution which is primarily led by artificial intelligence, and therefore horizontal problems, the classification, the prediction problems are getting solved, images are getting processed better. Consequently, the computers are thinking and acting and have the cognitive abilities of human beings, which is therefore making them to act not only intelligently but acting them independently, creating a very, very different universe that we live at. So coming back to conclude, as the infrastructure of every country improves, applications around artificial intelligence are going to improve, and we're going to see it in the next few years very, very distinctly. Industries that are going to transform, in my mind, are BFSI, mobility, which is mobility, auto, and so on and so forth, passenger, commercial vehicles, logistics, anything related to supply chain, healthcare, e-commerce, consumer products, and FMCG. If you are in this space, be aware of what AI is doing and how it is solving critical problems and removing inefficiencies in the value chain. With that, I will say goodbye. Hope you liked the video. Do share and comment as you deem fit. Look forward to meeting you soon. Thank you.